Good day, everyone. Today we will explore the instruments and methods used to measure evapotranspiration, which is the process where water is transferred from the land and plant surfaces into the atmosphere. This process is essential for managing water resources and planning agricultural activities. In this presentation, I will cover both direct measurement methods and indirect estimation techniques. So, what is evapotranspiration? Evapotranspiration, or ET, is the combined process of water loss from soil and plant surfaces to the atmosphere, critical for water resource management and agricultural planning. Also, methods range from direct measurements to indirect estimations. So we have direct measurements and indirect measurements here. So in the white side of the slide, we focus here on direct measurement techniques. The lysimeters are containers filled with soil and vegetation that simulate field conditions, allowing us to precisely monitor changes in water content over time. Similarly, tank experiments capture water loss in a controlled environment, giving us direct data on evapotranspiration. Now, on the other side of the slide, in cases where direct measurement is challenging, we use indirect method such as evaporation pans. So the Class A pan is a standard tool that measures open water evaporation. By applying a crop coefficient to the pan data, we can estimate the crop evapotranspiration. This method is particularly useful for large scale assessments or when direct measurement tools are unavailable. Next, we look at methods that measure ET under more natural conditions. Field experimental plots involve monitoring water loss directly in agricultural settings. Though these can be quite labor intensive, alternatively, sunken or Colorado tanks are partially buried to minimize the effects of environmental factors such as wind and temperature fluctuations, offering more stable measurements. Now, beyond physical measurements, several mathematical models estimate evapotranspiration. For example, the Blahnik Cradle method uses average temperatures and daylight hours, while models like Penman, Thornwaite, and Hargreaves incorporate various climatic parameters such as solar radiation, humidity, and wind speed. These equations allow us to calculate ET even in the absence of direct measurements. Now let's go to the factors affecting ET and mitigation strategies. So, evapotranspiration is affected by several factors, including temperature, humidity, wind, speed, and the characteristics of the plants themselves. Understanding these factors is crucial for accurately measuring ET. In addition, various strategies can help reduce unwanted evaporation, such as installing windbreaks, using floating covers or chemical films, and managing water depth in reservoirs to maintain cooler water. In conclusion, whether we are using direct methods like lysimeters and tanks, indirect methods such as evaporation pans, or mathematical models, each approach offers valuable insights into the process of evapotranspiration. Accurate measurement of ET is essential for optimizing water use in agricultural and ensuring sustainable water resource management. That will be all, and thank you for your attention.